final project, engineering 1035, Samuel Fink. Because we're online, we didn't do this as a team, we just did it alone. So this was our final project. Everything that we did up to this point was pretty much preparing us to do this final project, which was having our Lego robot in an obstacle course, basically just a square box or area with obstacles, and it needed to find a black square. So a little background. I just put these images in because they're a little easier to explain. We were using Simulink inside of MATLAB to do our programs or our modeling. So on the left side, you see some of the Lego EV3 robot specific boxes that we could use. You see there's a color sensor, the buttons on the robot, and just all speakers, the motors, everything. So we can put those into programs so we can make them do specific things. The little web you see on the right side is just an example from earlier in the semester. It's a relatively basic one where you see that we have the sensor and the two motors going. So this was just pretty much a distance threshold thing. And we'll actually see that in a little more complicated later. And then in the bottom middle, you'll see the function, and that's where it kind of got fun, where you could actually write code of inputs and outputs, and that lets you have your robot do things that are a lot more complicated. So that's just basically this whole we wrote a code, laid out our inputs and outputs, and that's how we get our results. The configuration for the robot I kept as it came because that just seemed to work the best for me. As you see on the left, that's the back of the robot, the two motors, and going to the port A and D. And then on the right side, you see the front of the robot. And the two sensors we used in this project were the top sensor that kind of looks like an eye, which is an ultrasonic sensor. And then the sensor that goes down has a CB on it. That's a light sensor. We used it as or it's a color sensor, light sensor, either way. We use it as a light sensor, not a color sensor. You have options on there. And that way we could detect the black square we have in our little obstacle course that you'll see a little later. Moving ports didn't really matter because you could just choose which ports you had everything go to. So we just kept it as it was. For our model, this is a very basic version. Like I said, most of the things that was done for this project was in the coding. So we have on the left top side, we have our color sensor, or as we had it as a light sensor, our light threshold, our set speed, and then our ultrasonic sensor, and then our distance threshold of 15, that's centimeters. Light thresh is just, I had to test it and set it as I was reading the live data from our robot so I could get that right. And then our outputs are just our port D and port A, our motors for our wheels. So then we'll look at our function or our code. So it's relatively simple. I tried to keep it simple just so I didn't want to get it too complicated where we run into issues. But I thought the best idea was an idea I got from one of the past projects we did in this class or assignments. It was where we taught the robot to back up when it ran into things. And I thought if it's just going to be in a square box with obstacles in the way, then what's a better way than just it going straight when it hits an obstacle, back up at an angle, and then keep going straight. And that way you can pretty much put it in any obstacle, and as long as there was nothing crazy in the way and things that the sensor would pick up, then it could find that black square eventually. So we have our case 0, which is just where we start out. It's our persistent state. And that's just both wheels get the same speed to it, so it should be just going in a straight line with 0 rotation. And then you see if the light sensor is less than or equal to the light threshold, which is on the last page, it would go to state 2, which if you jump to the bottom where case 2 is, you just see that it stops. So right wheel 0, left wheel 0, 0 rotation. Else if the ultrasonic sensor is less than the distance threshold, so therefore if it comes close enough, less than 15 centimeters away, it'll go to state 1. And then you go down to case 1, you see the right wheel -1, left wheel -1 times set speed, so that way it's backing up. And that's where our rotation comes in, because if it backs up and then just keeps going forward and running into the same object, it doesn't really do any good. So it rotates at 60, and that only affects its positive 60 on one wheel and negative 60 on the other, and that's what creates the rotation. And you can see that at the bottom in between the two ends, where you have the right wheel plus rotation, right wheel left minus rotation. And that's how you get your rotation. Still has the light sensor part, so that way, no matter what case it's in, if it hits the black spot, it's done. So we're gonna watch the video of this code running next. I ran it quite a few times with this robot, kind of ironing out some details. This is not the fastest or the slowest, but I think it gives you a good idea of what the robot does. Some of the obstacles I used probably should have been bigger, because you can see that the robot kind of clips the wheels on a few of what I used as water bottles. But what I was using before, which was paper towel rolls, just wasn't working as well. So, but you'll get a good idea of what happens. We're gonna watch that next. For our obstacle course, like I said, I'm using my mouse pad. It's dark enough. That one works pretty well. Depending on how it feels and how the bottles are feeling, it'll go quicker or slower than that on the many times I've tested it. So there we go, final project. Alright, well, thanks for watching, and I hope you enjoyed.